we have the load store bytes that, let's look at I think you're gonna see the unsigned, yeah, you're gonna see the signed and unsigned, right? I think we had this in one of the assignments or quiz. I think maybe the last one. It's still maybe there, I'm not sure. So, okay. So let's look at this one. So what was the load byte and byte? Do you guys remember?
The load byte on what?
And load byte unsigned. Let's quickly look at it.
LBU.
So what's the difference between them? Between LB and LBU? It's a very small difference. So first of all, what is the direction? Is it from memory to register, or is it from register to memory? The load. So is the load
from memory to register, right?
Yeah. So the loads, basically what we were just doing in this last example, right? The loads always take from the memory and reads from your memory and save it into your register. The store, so all of them, like a store word, a store byte, doesn't matter. So all the stores take from your register and save it to memory. So it's same syntax, but it's exactly opposite direction. Does that make sense? So yeah, I mean that there is nothing to it. It's either from memory to register or register to memory. So the difference between load byte and load byte unsigned is that load byte unsigned is not going to look at the sign of the number that you are reading. So let's get to a load byte unsigned. Okay, here. I think we talked about this last time also. So this is unsigned. I have LBU, and it's gonna look at register 23 for the address. So here's the address. And then in that address, I have these 4 bytes. Depending on big endian and little endian, it's gonna be either this first one or last one. But let's say just for the simplicity, is this first one. It's gonna be this 98 on that address.
Okay. Wait. Question. What is it usually? Is it usually big or small?
I think in MIPS it's small, and we're gonna see that actually right now.
Okay.
Yeah. And they have like benefits. You can read about it, and if you find interesting, maybe post it also on, I don't know, Slack or Island. They have like different benefits, like why they chose. Like there's some rationale behind them, like why they chose the way they did. Yeah. But I think on MIPS is small, and we're definitely gonna see it now, because we're gonna see if I run this example right now in MIPS, it's gonna be either this one or that one. So the load byte, so let's say it's this one right now, and when it's unsigned, it's just gonna take that number, that byte, which is only the two hex digits, so only 2 digits because the load byte, and put it in your register, and it's gonna pad it all by 0. That's unsigned. It's always pad by 0. If your number is positive, negative, it's gonna always pad it by 0. If you had load byte, it's gonna check if this number is positive or negative. If it was positive, only that byte. If it's positive, it's gonna still do zeros. If it's negative, it's gonna put ones. So can anyone know why is that? Like why it pads by 1 or Fs?
Isn't ones the same? 4 ones is the same thing as F, right?
Exactly. So 4 ones is F. So that's why it's F. But why is it 1? Why does it pad it 1 if it's negative?
I don't know.
So originally a negative number, so this is in 2 complements that we have here. So our 2 complements number are already having ones. So 9, for example, it's gonna be 1 0 0 0. 10001. That's going to be 9. And first of all, we know it's negative because the most left digit, we said this is the sign digit. So if this is a 1, that means it's negative. So if I now pad this with zeros, if you look at this number and the last one is 0 now, you're going to see this as a positive number, which is not true. We had a negative number. So to maintain this one, you have to put ones here. So it still is going to be the same negative number.
What if you put only 1 on the last one? Wouldn't that be?
You're going to change the value. So let's look at quick examples. So if we have, for example, 1001, right? What is this one? What's the value of this?
9.
Well, yes, in hex is 9, but as a number, what is the value? So how we do that? We said we're gonna flip and add 1, right? So it's gonna be 0 1 1 0, and then plus 1. It's gonna be 0 1 1 1, and then we're gonna convert it to decimal, which is gonna be 7, I think. 0 1 2. So 4 plus 2 plus 1. Yeah, so that's gonna be 7. And then we have set up a negative number. So the next step is to put in the minus sign. So this number in 2 complement, it's actually negative 7.
Okay.
Okay. So what about if I had, let's do another example. What if this number was not, let me try to write. Okay. What if I was doing not 1001, I was doing, let's say 1 1 1 1 and then 1001. What if this was my number? What is this value? Well, we do the same thing, right?
It's 110, right? At the end. And because you flip it, right?
Well, yeah, I'm gonna flip this. So it's gonna be 0 0 0 0 0 1 1 0. I'm gonna add 1. You see where I'm going with this?
7. Yeah. It's the same thing, negative 7.
And then it's the same thing. What is this one? This is 7, is negative 7. So these two are equal in 2 complements, basically. So
yeah, I see.
So to answer your question, if you had only the last one, so if you want to extend this one, if I put, do you see this part of the screen that I'm writing?
Yeah.
Yeah, okay. So if I put 1 and then zeros, bunch of zeros, and then 1001, if I convert this one, if I flip, it's gonna become 0 and then 1 1 1 1 1, you know, and then 1 and then 0 for this part, 1 1 0. If I convert this one to decimal, it's gonna be a large number.
Yeah.
And then I'm gonna put a negative sign. It's gonna be a very large number, or very small number if it's negative. But you see my point. So that's why to maintain this one, basically we have to pad it. If we want to maintain the same number, we have to pad it by ones. If it was negative. If it was positive, we just pad with zeros. So that's the difference. Does it make sense?
Yeah, it makes sense. Yeah.
Everyone get it? Yeah. Okay. So let's go back here. Now let's look at what we have. So we're gonna try to see the same thing in actual running it. So I have the same thing here, or I don't know if it's the same, but we have an array, basically 4 elements, and I'm doing LA T0X. So here I'm gonna have the address of the first element into T0. So nice. So let me skip this one for now. So far so good. And then here, what I'm doing load byte, and I'm passing that label. And I'm putting that content to S1. And then next time I'm doing the same label or the same address, because I have loaded this address in T0 with the offset of 2. And I'm doing 2 because it's a byte. I can do 2, right? If it was a word, you have to go every 4. But byte you can do 1 2 3 because it's 1 byte. So what should I get here? Or let's even forget this one. What should I get in this first one?
The first address, the first in the array.
The first thing in the array. So what is the first thing in the array? So what is the address? It's gonna be like the beginning of this thing.
Yeah, that
So
one.
101, I don't know, 1001 0000. And then I'm gonna get the first byte. So I'm gonna get first of all 2 digits only, right? Only 2 digits because the byte. But then what is this gonna be?
Oh, 1 2. I mean 0 1 0
0
1.
1. Yeah. I'm not sure because depends on the system. I think it's gonna be 6 7 if it's little endian. But let's see.
Okay.
So if we run, was it in S1? So if we run, look at S1. Yeah, we got 6 7.
So it is little Indian.
So it is little endian. Yeah. So we got only 6 7. So we got actually this 2 at the end. Does that make sense so far? Why we got 6 7?
Yeah.
Yeah. So what I could do, I could have an offset. I don't want to do 2 now. I want to do 1 first. So let's do 1. Or first of all, if I put 0 here, I should get the same thing, right? Because these are the same.
Because there's no offset?
Yeah, I can put 0, right? It's a valid number. So if I am loading the same address in this register and I'm putting 0, so I should get the same. So in S2.
Okay.
So to begin with that. So 6 7 6 7 in S2. Here, 6 7. Okay, so far so good. Now I'm gonna do 1. Run. I'm getting 4 5. So look at the number. This was 6 7, and then the next one is 4 5. So it didn't go to the next number, right? Because that's the order of the bytes. So if I want to like write the content, so this one is telling me that's number. This one is telling me that in this address 1001 0000, I have this content. But if I actually look close, I have 1001 000, and then this is gonna be 1 2 3. So this is like these 4 are kind of like the zoom in of this thing here, because the next one is gonna be 0 starting with 4. So the next one gonna be 4. So what we have, so here also again it's gonna be like 5 6 7, and then we have 8. So here we are not really showing the betweens of them, but we said that the memory is byte address. So that means every address is a byte. And this one, like, we are just grouping 4 bytes together because 1 byte is too small. And it is 32-bit system, so it is 32 bytes. If it's 64-bit system, basically we're gonna go like 64 blocks because we need even more memory. So this makes sense. So this is like the zoom in. So that's why. So when we go the first one, we said it's 6 7. So this number is actually stored like that, 4 5, and then is it 2 3, and then 0 1. So this whole number is stored like that in the memory. So that's how the blocks that it goes to. And this is little endian. If it was big endian, it was going from the other direction. So it would start, instead of starting from this way, it would start from that way. Make sense? Questions?
I have a quick question.
Yeah.
So at the bottom, like, you're using the load byte, not like the unsigned load byte. So why did it just do a 0 and then at the end put the 6 7?
Okay, so the different, so load byte unsigned always put zeros, always pad the number with zeros. That's the easy one. You agree on that?
Yeah, but in this case, you're not using load byte
Exactly.
unsigned.
Yeah, so I'm losing load byte. Load byte gonna look at the number. So depending on the number, if it's positive or negative, it's gonna pad the number. If it's a positive number, it's gonna pad with zeros. If it's a negative number, it's gonna pad with ones. Does that make sense? So it's gonna look at the sign.
And unsigned always pads with zeros?
Unsigned always pad with zeros, doesn't matter. And I can show you. So first of all, what I mean by negative and positive, how do I know it's negative or positive?
If it's greater than 9?
Yeah, so wait, let me go to this.
Okay, never mind now. I get it.
You get it? You know why I mean positive and negative?
Yeah, no, it's just I thought 6 had a leading 1. I forgot it was started at 9.
Yeah. So 6 is, I think, 0, 1, 1, 0.
Yeah, I forgot. Yeah.
So let's
Okay.
try that actually. So if I have this instead of 6, 7, I'm gonna put 9, which is 1. Wait, it doesn't start at 9.
It starts at 8, I think.
At 8, yeah, because 8 is 1, 0, 0, 0.
Yeah.
So if I put 9, which is still okay, and I do this one, I should get that once. I have to save. Let's save, run. So you see this one? It's 9, 7, but then I got all Fs.
Okay, yeah. All
Oh,
right.
yeah.
And then if I do unsigned, I have to get zeros. You see?
All right, yeah.
Yeah.
Cool.
Wait, if
Yeah.
you put 8, does it go all Fs? Or
Yeah, 8, I think it's 1, 0, 0, 0, right? So there is unsigned. I'm still gonna get zeros with 8, 8, 7.
Okay.
If I do load byte, I'm gonna get the Fs
Oh, okay.
because it's 1. If I put 7, I should get zeros again. And run is zeros. Yeah. And then basically. Not much to it, honestly. Like that, it's very so assembly. I think that's a good and bad thing about the assembly. It's very basic, like every instruction, but then it takes more to code. So that's it. And let's look at what else we had on the. So a store byte. So a store byte. Let's do this one also since we already did. So I can. So a store byte. The good thing about a store byte is that it's storing 1 byte, and since the memory is byte addressed, there is no padding going on anymore. So whatever you give it to store, it's gonna store, right? There is no padding because it has only 1 byte and you're giving it 1 byte to store. So it's gonna store it as it. So there is no signed and unsigned. So let's look, for example, let's delete this, or let's have the X. So what are we doing here? So we have this thing going on here. We are putting that in S0. And then we are doing store byte, and we are giving S0 and X. So let's comment this one for now. So I have a number in S0, and then I'm doing a store byte S0X. So now this time is the opposite direction. So it's going from S0 to X. So if you look at this one, and I'm gonna make this simple. I'm gonna make this first one to be clear. I'm gonna put like all, let's say put all ones. So 1, 2, 3, 4, 5, 6, 7, 8. So we can see the change. So I run, assemble, and run. So here in the memory, you see this last one, and we established that already. That is our first byte, right? We saw it in the previous example. It became 9, 8, and that is the first byte of our S0 that we gave it to, 9, 8. And it's not changing the other ones. So if I put zeros there, even though it's a 9, if I put all zeros, it's gonna just change that 9, 8, because it's like the memory is byte address. So we have a like 1 byte, and we are giving it the address for a 1 byte, and it's just storing it there. So it's not gonna change anything else. It is the easier one. But the only thing is that it's gonna take your first byte. So basically the last 2 digits here. So any questions?